Good morning, everyone. So today we are going to discuss about remaining special semiconductor devices. So today's topic is photodiode. Okay. So before going to discuss about photodiode, once I would like to uh, revise our last class topics. What is our last class topics? In our last class, we are discussed about what? So we are discussed about UJT as well as varactor diode. So what is meant by varactor diode? Already I said that the name itself indicates varactor diode means variable capacitance diode. So here these variable capacitance diodes are used to produce the capacitance. Means in variable capacitance diode, the diode acts like a capacitor, variable capacitor. Okay, so how the diode acts like a capacitor and under which condition the diode acts like a capacitor means under reverse bias condition it acts like a variable capacitor. Means when reverse voltage is applied to the diode, negative voltage is connected to the N type and the positive is connected to the P type, then the diode is under forward bias condition. But in varactor diode, positive terminal of the battery is connected to the N type and the negative terminal of the battery is connected to the P type. So in this way, the diode must operate in forward bias, reverse bias condition. So under reverse bias condition, the PN junction diode acts like a varactor diode. Why? Because under reverse bias condition, whole the majority carriers move towards the battery and the minority charge carriers will move towards the junction. Because of that, only the immobile charge carriers move towards the junction. So here the P is connected to the so here it is connected as means the P is connected to the negative terminal and N is connected to the positive terminal, so that now the diode is works under reverse bias condition. And this region is called deflection region. Here negative acceptor and positive donor ions are negative acceptor and positive donor ions are entered from one region to other region. First, cause of their insufficient energy, they try to enter, but they are not crossing the barrier. They are appeared across the barrier and forms the potential barrier. This potential barrier will oppose the flow of remaining mobile charge carriers, means holes and electrons. So in this way, this barrier acts like a dielectric media and this p-type semiconductor acts like a one of the electrode and the n-type is more one of the electrode. So finally these two are the electrodes and the dielectric material will separate these two electrodes. Finally, it acts like a capacitor. Okay, the varactor diode means simply the diode under reverse biasing condition acts like a variable capacitor. Why it is not capacitor? Variable capacitance means, so here this width may be increased or decreased depends upon the reverse bias voltage. By increasing the voltage, reverse bias voltage, the width must be increased. By decreasing, the width must be decreased. In this way, the voltage, by increasing the voltage, the width must be increased as well as decreased, so that it acts like a variable capacitor. And while coming to the next one, in our last class we are also discussed about UJT, uni-junction transistor. So while coming to the uni-junction transistor, it consisting of only one junction that is made in between emitter as well as base. So UJT, here one n-type semiconductor bar is there into which heavily doped p-type bar is diffused. So this is n-type silicon bar into which one p-type semiconductor bar is diffused. So this p-type semiconductor bar is heavily doped. Okay, p-type semiconductor bar is heavily doped, and this heavily doped p-type semiconductor is inserted into the n-type bar. And the two sides of n-type, bottom as well as top, are attached to the ohmic contacts. So these are termed as base 1 and base 2. These are termed as base 1 and base 2. So here P is considered as emitter terminal, and the n-type semiconductor, while attaching to ohmic contacts, these two are called base 1, base 2. Why? Because these two are having same name means these are attached to the bottom and top surface of n-type semiconductor bar. These two are attached to the top and bottom side of n-type semiconductor bar. So that it is only one terminal, but because of two sides it is considered as B1 and B2. So see here, finally we are having only one base terminal, one emitter terminal. Only one junction is formed between the P and N. That's why this is called a uni-junction transistor. Okay, it having three terminals, so that it is called a transistor, but it having only one junction like diode, it is called a uni-junction transistor. And while coming to the characteristics, initially by increasing the voltage, the current must be increased. So by increasing the voltage, the current must be increased. By decreasing the voltage, again we increase the voltage. After certain means after it reaching the maximum, the current returns to the minimum value. So after reaching to minimum value, it is again going to increase. So where it is start to going increase is called cutoff region, and where it is try to decrease is called negative resistance region, and where it is again increased is called saturation region. So these are the different topics we was discussed in our last class, and now we are going to discuss about more one special semiconductor device that is called photodiode. And see here, the name itself indicates photodiode means photons. If the diode works based on the imposing of photons, that's why it is called photodiode. So what is meant by photo or photons? So what is the name of the energy that must be delivered from the photon is called what? Light energy. What is the name of that? Light energy. Is it clear? So in photodiodes, photons must be reached the junction. Photons must be reached the junction. So cause of photons, the current must be produced, and this current is directly proportional to the amount of light falling on the junction. So this is the principle involved in the photodiode. See here, this is the symbolic representation of photodiode. In symbol it is clear. The light energy must be fall on the junction, PN junction. So when this light energy falls on the junction, the flow of electrons and holes must be increased. The current must be occurred. So that it will indicate what? here the amount of light energy is converted into the electrical energy. So amount of light energy is converted into the electrical energy. Is it clear? What is the theme involved in the photodiode? The photodiode will convert the light energy into electrical energy. So photo means what? Photons. Photons, light energy. If we apply the light energy across the junction of PN diode, the amount of current must be increased. That's why this is called light to current converter. Once see this slide, a special type of PN junction device that generates currents when exposed to the light is known as photodiode. So photodiode means what? It is a device that generates currents. When it will generate current? When it is exposed to the light. Okay, it is a device which will generate the current when it is exposed to the light is known as what? Photodiode. And it operates in reverse bias mode and converts light energy into electrical energy. So this is about what principle and what is meant by photodiode. And see here, what is the principle? Means which name we allot to the principle. The conversion of light energy into electric energy is called photoelectric effect. What is the principle involved in the photodiode? It is called photoelectric effect. It is meant by photoelectric effect. The light energy is converted into the electric energy. The name of the principle is called what? Photoelectric effect. The operating principle of the photodiode is such that when the junction of this two-terminal semiconductor device is illuminated, then the electric current starts flowing through it. What happened here? The operating principle of photodiode is such that how it is that when junction of this two-terminal semiconductor device junction of this two-terminal semiconductor device is illuminated to the light, then only the current flows through it. So when this junction, if it is a PN semiconductor diode, when this junction illuminated to the amount of light only, cause of light only, if the flow of energy carriers will be occur, then only that is called what? Photodiodes. Okay. This is the principle involved in the photodiode. What is the name of the principle? Photoelectric effects. What is meant by photoelectric effect? When some amount of light must be imposed on the junction, PN junction, then the movement of charge carriers will be occurred. That is called what? Photoelectric effect. Okay. And see here, this is the construction of photodiode. This is the construction of photodiode. So while coming to the construction, see here, initially we take an N-type semiconductor material. First we would like to take an N-type semiconductor material into which heavily doped P-type is inserted, and then you attach two ohmic contacts across the P-type. One is called anode. Here it is P region, that's why it is called anode, and N region is called cathode. Is it clear? First you take one N-type semiconductor, then you diffuse heavily doped P-type region, and the name of the P-type region is called anode, and the N region is called cathode. And see here, Case of p-type having majority charge carriers holes, this is called anode. And n-type region having the majority charge carriers of electrons, so that it is called cathode. And above the p region we diffuse a layer of silicon oxide. SiO2 layer is diffused over the p region. So which layer is diffused? So SiO2 layer, silicon oxide. So see here, over which silicon nitride coating is there. So now the amount of light energy, that means radiation, is fall on the p-type surface. Automatically, cause of this light, the temperature must be increased across the junction. By increasing the temperature, cause of light again and again, automatically the breakdown of the junction is occurred, and the flow of current must be from one area to other area. So in this way, the flow of electrons must be occurred from one area to other area. And see here, while coming to the construction, whatever I explained that is there in the slide, once see. The PN junction of the device placed inside in a glass material, and this is done to order to allow the light energy to pass through it. With the help of glass material, we can easily impose the light energy. Less energy also must be imposed clearly and easily, means less energy must be applied on the junction gives breaking of the junction. And as only the junction is exposed to the radiation, thus the other portion of the glass material is painted black or it is metallized. As only the junction is exposed to the radiation, the other portion of the glass material is painted black or it is metallized. The overall unit is of very small dimension, nearly is about 2.5 mm. Is it clear? The PM junction of the device is placed inside of glass material. Cause of this, it will allow the light energy to pass through it. As only the junction is exposed to the radiation, thus the other portion of the glass material is painted black or metallized. So the overall unit is of very small dimension, nearly it is about 2.5 mm. And it is noteworthy that the current flowing through the device is a microamperes, means very very small, and it is measured through the ammeter. Means a small amount of dimensions, 2.5 mm, will give the current of microamperes. And see here, these are the VI characteristics of photodiode. So the name itself indicates VI characteristics means what? Voltage and current characteristics are called VI characteristics of photodiodes. VI characteristics of photodiode. So here we indicate what's voltage and I indicate what's current. If the curve that must be drawn between voltage and current, then this is called VI characteristics of photodiode. And see here, the increase in the voltage, the current must be increased. So these are the VI characteristics of photodiode. So see here one term is there, dark current. So what is meant by dark current means by application of voltage, no current is there. In the absence of light, no current is there. So that situation is called what? Dark current. So by increasing the light, thereby by increasing the voltage, the current must be increased. Okay. But in the absence of light, no current will be produced. So this region is called dark region, and the current produced in the absence of light is called dark current. But that is very less, few, negligible. That's why it is called dark current. And while coming to the applications, cause of it is operated with light, photodiodes are used in photo detection systems. Where it is used? Photo detection systems. And these are also used in demodulation circuits. Also used in demodulation circuits. And also used in logic circuits. And OR circuits are multiplexer, demultiplexer, decoder, encoder. So while coming to the applications, one of the important application is switching. The photodiodes are also acts like a switches, and these diodes are used in optical communication systems also. What is meant by optical? If any material is made with glass, then that is called optical. Optical communication system some means communication systems, mainly it works with cables, transmitters, receivers, etc. If any communication system is made with glass material, then where we impose the light easily, na? So that photodiodes are also used in communication systems. And in high speed reading of punched cards and tapes also. High speed reading of punched cards and tapes also, we are using photodiodes. Where we are using the photodiodes? Photodiodes are used in photodetection systems, demodulation circuits, logic circuits, and also used in switchings, also used in optical communication systems, and in high speed reading of punched cards and tapes. High speed reading of punched cards and tapes, and also used in reading of film soundtracks. What is the main application of photodiode? These are also used in reading of film soundtracks. Where it is used? Film soundtracks. So these are the wide varieties of applications of photodiode. What is our first one? It is used in photo detection system, and used in demodulation circuit, and used in logic circuits. In switching circuits also photodiodes are used. And in optical communication system, which kind of communication systems we are using photodiodes? In optical communication systems. And these are also used in high speed reading of punched cords and tapes, magnetic tapes, punched cord recorders, like that. And also used in reading of film soundtracks. Also used in reading of film sound tracks. Last one, these photodiodes are also used in production line counting of objects. Where it is used? Production line counting of objects. So these are the applications of photodiode. And while coming to the operation, see here in this photodiode, a very small amount of reverse current flow through the device, that is termed as dark current. So whatever the current that must be flow through the device under the absence of light is called what? Dark current. Why it is called dark? It is called so because of this current is totally the results of flow of minority charge carriers, and is thus flows when the device is not exposed to the radiation. In the photodiode, a very small current flows through the device, that is termed as the dark current, and it is called because this current is totally the result of flow of minority charge carriers only. When the device is not exposed to the radiation, if you are getting a fraction of current, very little bit current, that is only due to the minority charge carriers, then that is called what? Dark current. It is very important question. It may be 1 mark question or 3 marks question, like intrinsic stand-off ratio in UJT. It is also very important question. Okay, what is meant by intrinsic stand-off ratio? That is very important question. I like that. Here dark current is also very important question. Okay, what is meant by dark current? Small amount of current flow through the device due to the minority charge carriers in the absence of light is called dark current. Sometimes we also said in the absence of radiation, light, radiation both are same. And see here, while coming to the operation from the diagram. So when we apply the reverse bias, means N is connected to the positive terminal of the battery. P is connected to the negative terminal of the battery. Now the diode undergoes into the reverse bias condition. N is connected to the positive terminal of the battery. P is connected to the negative terminal of the battery. Now the diode works under reverse bias condition. When the diode works under reverse bias condition, the majority charge carriers of electrons move towards the positive terminal and the majority charge carriers of holes move towards the negative terminal. So that whole majority carriers move towards the battery, there is no chance to move towards the junction. But only few minority charge carriers, holes in the N and electrons in P, move towards the junction. So these minority charge carriers cross the junction for few minutes in the absence of light. So due to this minority charge carriers, whatever the current we are getting, that is called what? Dark current. So due to this minority charge carriers, whatever the current we are getting, that is called what? Dark current. So in the photodiode, a very small current flows through the device. That is due to what? Minority charge carriers, holes in N and electrons in P. After this, the junction is formed due to negative acceptors N side and positive donors from the P side will form the depletion region. So cause of this negative acceptor and positive donor ion, depletion region will be formed and the width of the depletion region must be increased again and again by the application of reverse bias voltage. Is it clear? By applying the reverse bias voltage VR, the width of the depletion region will be increased. So when the depletion width region will be increased, at that moment we apply the lights, we apply the radiation. When the radiation must be incident on the junction, when amount of light must be incident on the junction, suddenly the covalent bond between the negative acceptor ions and the positive donor ions will be broken. So covalent bond between the negative acceptor ions and the positive donor atoms will be broken. Now automatically the flow of current will be occurred. So now the majority charge carriers also moved from one to other junction. So in this way it will convert the amount of light into the electrons. So this is the construction and operation of photodiode. Whatever I explained, that is there in the slide. Once see. The electrons present in the p side and holes present in the n side are the minority charge carriers. When a certain reverse bias voltage is applied, then minority carriers holes from the n side experience a repulsive force from the positive potential of the battery. And similarly, the electrons present in the p side, electrons are what? Minority in the p side, experience a repulsion force from the negative potential of the battery. So finally, minority charge carriers will repelled from the battery and the majority charge carriers attracted towards the battery in reverse bias condition. So what happened in reverse bias condition? Majority charge carriers move towards the battery and the minority charge carriers will repelled from the battery. That is here. The electrons present in the p side and holes present in the n side are the minority charge carriers. When a certain reverse biased voltage is applied, then minority carriers, holes from the n side, experiences repulsive force from the positive potential of the battery. Similarly, The electrons present in the p side experiences a repulsion force from the negative potential of the battery. And due to this moment, electron and hole recombine at the junction. So cause of this, deflection region will be increased. Due to this moment, a very small reverse current flows through the device is known as what? Dark current. And the combination of electron and hole at the junction generates neutral atom at the deflection, due to which any further flow of current is restricted. So what happened here? Due to the moment of minority charge carriers, electrons and holes, they will recombine at the junction. So resultant what happened? Generating the deflection region at the junction. So due to this movement of minority charge carriers, a very small reverse current flows through the device. That is known as what? Dark current. And the combination of electron and hole at the junction generates neutral atom at the deflection, due to which any further flow of current is restricted. So now the junction will be illuminated to the light. After we are getting dark current, after forming the potential barrier, there is no chance for increasing the current. At that moment, now the junction will be illuminated to the light. Whatever I explained, that is only there here. So now the junction of the device is illuminated, means exposed to the light. As the light falls on the surface of the junction, when the light falls on the surface of the junction, automatically the temperature of the junction going to increase. Is it clear? After applying the reverse voltage, deflection region will be formed, but due to minority charge carriers, small amount of current is occurred. That is called dark current. And under that condition, now the device is exposed to the light, or it is illuminated to the light. Both are same. So when the light falls on the surface, whereas the light falls on the surface of the junction, the temperature of the junction gets increased. This causes the electron and hole to get separated from each other. This causes the electron and hole to get separated from each other. The two get separated, then electrons from the inside gets attracted towards the positive potential of the battery. What happened here? The two get separated. The electrons from the inside gets attracted towards the positive potential. Similarly, holes present in the p side gets attracted towards the negative potential of the battery. So this movement then generates high reverse current through the device. This movement then generates high reverse current through the device. With the rise in the light intensity, more charge carriers are generated and flow through the device. Means when light is incident on the junction, the temperature across the junction will be increased, automatically the bonding between the negative acceptors and positive donors will be reduced. Breaking of covalent bond occurred. So the flow of electrons and holes moved from one region to other region. So with the rise in this light intensity, more charge carriers are generated and flow through the device. With the rise in the light intensity, more charge carriers are generated and flow through the device. So thereby producing a large electric current through the device. This current is then used to drive the other circuits of the system. So we can say the intensity of the light energy is directly proportional to the current through the device. Directly proportional to the current through the device. And only positive biased potential can put the device in no current condition in case of the photodiode. Only positive biased potential can put the device in no current condition in case of the photodiode. And see here, our next topic is extended version of diode is called what? Phototransistor. So there the diode is made with two semiconductor materials, one is p-type and other one is n-type. But here the transistor is made with three semiconductor materials, whether maybe PNP or NPN. If it is PNP, it is made with two P semiconductors and one N semiconductor. And if it is a NPN type, two N-type materials are there, one P is there. So in this way, phototransistor is a three-layer semiconductor device which has a light-sensitive base region. Phototransistor is a three-layer semiconductor device which has a light-sensitive base region. And the base senses the light and converts it into the current which flows between the collector and emitter region. So what is meant by phototransistor? It is a three-layer semiconductor device which has a light sensitive base region. Now the base senses the light and converts it into the current which flows between the collector and emitter region. And here the symbol of phototransistor is there. Once see, the light is exposed on the collector base junction here, where we impose the light across collector base junction. Why? Because emitter base junction is under forward bias condition, so that no need of exposing the light. But collector base junction is in reverse bias condition, so that there we expose the light. Once see the slide, the arrows here indicate what? Light incidence on the base of the transistor, where we apply the light across the base. And consider the conventional transistor is having open terminal base circuited. The collector base leakage current acts as the base current ICBO. Generally we know already collector current IC is equal to beta IB plus 1 beta ICBO. This is a general expression. It's not a phototransistor expression, normal transistor collector current expression. We learned it in already our first class of IC is equal to what? Beta IB plus 1 plus beta into ICBO. So here IB is the base current, ICBO is the leakage current. As the base current IB is 0, if it acts in open circuit. Why if base current 0, it acts like an open circuit? See once, base is located in between emitter and collector. If it is open circuit means no current is there in base means it simply acts like an insulator now. So with base terminal no emitter, no collector, carriers move from one area to other. Is it clear? So this is general expression of current, our transistor. And here IC is equal to what? 1 plus beta into ICBO when IB is equal to 0. And the above equation shows the collector current is directly proportional to the current base leakage current. That is, IC increases with increase of the collector base region. Collector base region. And while coming to the construction one, see here this is the construction. Initially the phototransistor P material or the N material both are semiconductor. Here either germanium or silicons are used for fabricating the phototransistor. The small hole is made onto the surface of collector base junction for placing the lens. We take the help of lens to insert the light into the base. The lens focuses the light onto the surface. So nowadays the transistor is made of a highly light effective material. The emitter base junction is kept at forward biased and the collector base junction is at reverse biased. When no light falls on the surface of the transistor, the small reverse saturation current induces on the transistor. What happens here? The emitter base junction is kept at a forward biased and the collector base junction is always reverse biased. Then only the transistor operates in active region. So that when no light falls on the surface of transistor, the small reverse saturation current induced on the transistor. And the reverse saturation current induces because of the few minority charge carriers. The reverse saturation current induces because of the few minority charge carriers. And the light energy falls on the collector base junction and generates the more majority charge carriers which adds the current to the reverse saturation current. What happened here? The transistor is made of a high light effect material. The emitter base junction is kept at forward biased and the collector base junction is at reverse biased. When no light falls on the surface of the transistor, the small reverse saturation current induced on the transistor. The reverse saturation current induced because of the few minority charge carriers. Is it clear? So the light energy falls on the collector base junction and generates the more majority charge carriers which adds the current to the reverse saturation current. And see here, these are the VI characteristics of phototransistor. So here these are the VI characteristics of phototransistor. The phototransistor is widely used in electronic devices. See here, when the light illuminated is increased, the flow of current is also increased. In the x-axis, we will take the illumination of the lights, width for square centimeter units, and this is the current in microamperes. So when the light is going to increase, the current is also slowly increased. Of course, it is in microamperes, but by increasing the lights, the flow of current is also must be increased. So means the light amount of light illuminated on the junction is directly proportional to the current produced. And while coming to the applications, these are used in smoke detectors, infrared receivers, CD players, lasers for sensing of the lights. And whatever I explained, that is there only in the slide. Once all of you check the slides, okay, whatever I explained with help of diagram, that is only there. And while coming to the applications, see here, these are used in the relay circuits, measuring devices, and used in the lights operated switches, and also in photo relay circuits. Okay, so next one is photovoltaic cell. Photovoltaic cell is simply like the diode. Okay, so the energy is electron is known as photoelectrons, and the phenomena of emission of electron is known as photoelectron. Means when the presence of light, if electrons are produced, then that is called what? Photoelectric effect. So here the photovoltaic cell is a semiconductor device that convert the light energy into the electrical energy. Same, this is like a diode. And electronics in the materials are joined together by the bond only. Simply it is like that diode. And now these photovoltaic cells are used in exposure controllers, research satellites and TV transmitters, microwave repeater stations, solar power stations, and also used in aerospace projects and also used in laboratories. So these are the different applications of photovoltaic cells. So finally today we are going to discuss about photoelectric effect devices. Those devices, they work based on the principle of photoelectric effect. Okay, now I would like to end the session. In tomorrow's session we will meet you again.